Hello everyone, welcome to Computer Science E76, Tuesday edition. So today what we are going to be talking about is Android, of course. And so last time we really started laying the foundation for using the SDK specifically and being able to implement some of the native applications that we're going to be using now for the next couple of weeks. And really starting with today, are we really going to dive in and get into some of the really interesting things, including talking a bit about some of the layout options that are available to you to create a nice UI in Android and connecting programmatically to that layout so that you can cause events to happen when the user actually interfaces with those UI elements in your activity. And also a little bit later towards the end of the day, we're going to start talking about some of the resources that you can package along with your application, including things like sounds and images, color styles, and arbitrary XML files to use within your application as a whole. And you're going to need to know all of this stuff, not only for your Student's Choice project, but also for the Staff's Choice project, which is going to be released just after lecture. And basically, what you need to know about this project is that you're going to be implementing an Android version of a game called N-Puzzle. So if you're familiar with these toy games, they came in little plastic squares with about 15 plastic tiles or so, and you'd be able to slide them around. There'd be one tile removed, as you can see in this image above. You could actually slide the remainder around, and the point of the puzzle was to shuffle them up and then be able to relatively efficiently get them back into a sequential order. And so we're going to be implementing that on Android in an Android form, but instead of using tiled numbers, you're actually going to be taking an image, breaking it apart into a certain number of tiles, and from there shuffling them up so that the user can interface with your game, with your application, to create then the original shuffled, or rather unshuffled version of that image. So here's just an example. For example, on the left there's a shuffled tiled version, and there's one that's on the right. So it's not quite sufficient to be able to take an image, break it up into a certain number of tiles, and pseudo-randomly shuffle them up. Because it just so happens to be the case that for certain types of shuffled boards, some of them are in fact impossible to solve. And in fact, this seems to be a problem when you have an even number of tiles on the board. As you can see in this middle option here, you can't just randomly shuffle them up, and some of them won't actually be able to be solved. And so there's a little bit of a discussion in the project specification about what you have to do, but essentially, for those tiles or for those puzzles that you have to create where you have an odd number of tiles, or another way to think of it is an even number of rows and columns. So notice that because we're actually missing, because we subtract one of the tiles out, when you have an even number of rows and columns, you happen to incidentally have an odd number of tiles. Then what you're going to do is, instead of pseudo-randomly shuffling them, you're just going to reverse all of the tiles. So go from 15 down to 1 basically, but then swap these last two. And again, there's more information in the project specification, but it's really sort of an interesting problem for us to be able to look at this and try to decide how we can pseudo-randomly assign or shuffle these tiles so that you can then create an interesting game. Again, we're not going to have to do that for this one unless you elect to actually design that. If you do choose the option, and this is purely optional, you don't actually have to do this in your implementation, but only if you really want the challenge, the algorithmic challenge of completing this aspect of it. One of the things that you can do is then come up with a way of, first of all, pseudo-randomly shuffling them, and then figuring out if that configuration is actually solvable or not. And so half of those configurations will be solvable, half of them will not. And so if you determine through some heuristic that you're not able to solve that particular puzzle, then you'll have to regenerate a new one. But again, that's an optional portion of this, and something that I think is kind of fun, but is not required for this project as a whole. So just to give you an idea of what this sort of thing is going to look like, this is an example of the game, and this is nearly solved. And I took a couple of minutes before the class. I realized that when I wrote this app last year, I got really, really good at being able to solve these puzzles, because after a while, when you're testing it, you have to do it a lot, and you just sort of get a feel for how this game actually works. But then earlier today, when I was trying to pre-solve it for you, I realized, man, I'm really getting bad at this game. But anyway, just to show you something towards the end of one of the things that you have to implement, just because I had to pre-solve it, if you actually solve the puzzle, what it has to do is that it has to show you a new activity, congratulating you that you have solved this puzzle, showing you how many moves it actually took you. You can see how terrible I am at this in this game. It says I did it in 105 moves, and you can move on from there. But basically, if you were to go from the initial part of this game, you're going to have 3 different activities in your application, in your task that you're going to create for this staff's project. The first one is a selection menu like this, like you can see here, where you will have to select, you, the user, will have to select one image that you actually want to play with. You can see we have a nice little list view here, so I can select an image. Then what's going to happen is you are shown as the user the unshuffled or the solution for about 3 seconds, as you could see just briefly there for a moment, so that the person knows what it should actually look like at the end. And then you're presented with the tile or the shuffled version, as you can see here. So just to go back and show this to you again, I'll show you, I clicked on one, it gives me a little countdown, and then it shows me for about 3 seconds the solved version before it switches to the unsolved one. And so in this case, this is the staff solution, and we will post this APK file on the website so that you can actually take a look at it and see how it works, see how it might have to be, how it should behave. But keep in mind that some aspects, we've implemented some additional things in the staff solution that you do not have to implement in your own. Namely, the pseudo-random shuffling that I mentioned just before. Notice that it's not in a full reverse order and is in fact pseudo-randomly shuffled. That's not something that you have to implement. It's just an optional thing for you to do. But if you decide to do it, here's an implementation example of how you might decide to do it. So you refer to this application because it might be a good way of seeing how we do some things. And but keep in mind that we added some additional flair to it that you don't have to in yours. Like, for example, there's actually some neat little animation. When you click on a tile, it will actually shift over from one section to the next. You don't have to implement animation or anything like that. You can just have it swap from the current position to the empty position. But there is an important aspect of this project that I think you should pay a lot of attention to, particularly at the onset when you're starting to plan how you're going to implement this application. And that is that your program should actually take one of these images and dynamically tile that image into the appropriate number of tiles. What I mean by that is that we should be able to take whatever images you have bundled in your application, remove them, put some of our own in there, some original, just completely unaltered images, and your application should be able to cope with those new images. And so what that means is that you should then be able to take an arbitrary number of difficulties for this game. So for example, right now we're on an easy mode because we have only 8 tiles, or a 3x3 square, but you should also be able to make it so that it's much more difficult as well, including a 5x5 tile. So you can dynamically take one of these images and break it into the appropriate number of images, or the appropriate number of tiles, and lay them out that way. So this involves a couple of important things. First of all, when you are deciding how large to make your game, notice that one of the things that you will also have to implement, or well, this will sort of come for free. By the way, this is a little bit of a hint. This functionality right here, where I apologize, it's being kind of, let me try doing it this way here. All right, so and it's the cable that's torquing the device a little bit. So come on, don't move. So as you can see here, no matter how I decide to orient the device, it will actually appropriately size and resize all of not only the entire board, but also the tiles themselves. We're not just arbitrarily shrinking all of the tiles, we're actually recreating all of the tiles from the original dynamic, or from the original image, and dynamically creating each of those tiles. So there's a couple of things to keep in mind. First of all, notice that this image happens to be shrunk to the largest size that it possibly can be on the screen, while retaining its aspect ratio. And what I mean by that is that if I were to take one of these images, for example, that's more horizontal, notice that it doesn't look squished. It's a little bit smaller on the screen, but that's okay. We're not elongating it. We're not making it a little bit taller to make it fit totally on the screen. But what we're doing is we're resizing both the width and the height a corresponding amount so that it fits as a whole on the screen in an appropriate amount. So that's one of the first things that you have to do, is to figure out how you can accurately resize this image without altering it, without distorting it, without stretching it or shrinking it or doing any of those things, to resize that photo so that it fits full screen on the device without any of those bad things actually happening to that display. Then the other thing you have to worry about is once you have resized it, then you might want to decide how you're going to tile it. So then you actually have to divide that resized image into tiles. Or you could do it the other way around if you want. You could first tile it and then resize each of the individual tiles so that in aggregate you get this sort of thing as well. But when you do those calculations dynamically, what you'll notice is that you can actually then reorient the device as like this, and it will then be able to recalculate each of those things in an appropriate way, and you will be able to play this game without having any distortion or change in the aspect ratio of the image. And I dare say that this is going to be one of the more difficult aspects of this project, is all of those calculations, making sure that it's going to look appropriate on the display, figuring out how the layout is going to work, what layout options you're going to use, what layout scheme you're going to use, so that you can actually set these tiles up on the display and be able to interact with them in that manner. And so we will have a little bit of a walkthrough. I believe it's tomorrow, and Tommy will get you started on this project. And so I recommend not only attending that, but also watching the videos a couple of times if you want to get started on this program and have fun with it that way. So again, we'll post the project specification later tonight. All right. Now, coming back to this stuff. Last week, what we started talking about was actually creating a UI in an activity in Android. And we might recall that when we talked about an activity is basically just the thing that a user interacts with. And there's this whole life cycle that an activity has to go through in order for it to be created, when a user actually interacts with it, and when that activity can actually be destroyed by the system. And we'll see more about that in a little bit. There's some other things that we have to talk about before we can actually talk about when we can implement other aspects of this activity life cycle. But as you might recall, there were a couple of ways that we could actually create a UI within this activity, and we would do that within that method that's created, that method at the onset, that's called at the onset of the creation of the activity. And so we can either define the UI either programmatically, as we can see at the very top, or we can create it using some XML files and then be able to instantiate that layout that we've created in an XML file and display it in our activity. So recall then that the very simple Hello World applications that we had last week just use some text views, which are just some objects that are just going to display some text on your activity in a very sort of simple but perhaps still meaningful way. But if we want to create more complicated UIs, then what we need to do are actually to have a whole bunch of these views in aggregate. Perhaps we want to not only have a text view, but also a button. Maybe we also want to have a little field so somebody can enter in some text. There's actually a way that a user would be able to input some text to our application, or perhaps we want to display a picture, or perhaps we want to do any number of things. We have to then use a view group, which can then hold a collection of these views and display them to us as a user. And so this is a pretty abstract concept, using a view group, but as you'll see, these view groups can really be thought of as layouts. You can think of different view groups as being different types of layouts. So perhaps you want to have a view group where you can actually show these views in a stacked format, a vertically stacked format, so one is right on top of the other. Perhaps you want to have a different type of layout where they're instead stacked horizontally, so that there's one to the left, to the right, and perhaps there's other layouts that might be useful as well. And so here are some example of layouts that you might or might not use throughout your time here. Some of them are going to be you're going to see quite a bit, and some of them you may not use quite so much. But there are, in fact, a whole bunch of layouts that are view groups that allow you to collate a whole bunch of views together and display them in some way on your screen. So frame layout, for example. Linear layout is that one that I mentioned just a second ago, where you would be able to stack items vertically, one on top of the other. Relative layout is going to be pretty useful and pretty interesting because you can sort and place objects arbitrarily relative to other objects on the screen. That's going to be pretty nice and will help us overcome some of the issues of fragmentation in the platform and so on. And some other ones, let's see, the table layout is also pretty nice because you can create a table. It's sort of similar to an HTML table, but there are some key differences that might, if you come from an HTML background, might frustrate you a little bit, at least at first, and some other ones as well. So we didn't get a chance really to talk about some of the layouts, but if you go to the course website, we do in fact have some of the latest source projects available for you to download and try on your own Eclipse as well, so you can see how we're doing some of these layouts. But the most simple type of layout that we might actually have is something that looks like this, which is just, again, a very simple Hello World app, but we have now several views, one on top of the other. Now, the reason that we have to use a layout for this is when we pass a view to our activity, we can only give it a single view. So really, if you might recall that slide just a second ago, we had a view group, which then had several children associated with it. In order for us to show more than one view, we have to have a view group that can then house, as children, several other views within it. So you might then actually have, like we saw in this slide, you might actually have, as the parent node, a linear layout that then can hold several children. So in this case, we have a linear layout that's this view group at the very top. It's the parent hierarchy. It's the very top node in this tree. And then you have as children to that several text views that can then display each of those phrases that we saw just a second ago. And you can make it a little bit more complicated than that as well, as we'll see in some future examples where you can actually nest view groups as well. So you could have a linear layout that is a parent to another linear layout, so that you can basically create a faux table in that way if you wanted to have a linear layout that had stacked vertically layouts, and then the child's linear layout then is able to use views in a horizontal fashion as well. So if we were just to take a look at this code, what we're doing is we're not creating this code or this layout programmatically, but we're going to define it in XML. And then in our application, in our Java code, we're just going to tell the activity that we want to use this layout that we have defined here. So just to bring this idea home a little bit, all of the code for the next few activity projects that we're going to look at basically just look like this. Just very simple. It's what we saw with the Hello World application. All we're doing is instantiating our activity, creating our activity, and setting the view to the parent node in that layout XML file that we're going to see in just a moment. Now, for those of you sitting here as students, you're actually very lucky, because previously, when we dealt with layouts in Android, we pretty much did everything in XML like this. And you would have a little bit of a preview that Eclipse could show you, or one of the Android SDK tools would show you that Eclipse would actually piggyback on. But nowadays, they actually have a much better WYSIWYG editor that you can use to create your layouts as well. What we're going to do over the next few examples is to show you how you can accomplish each of these things in XML, but realize that when we start getting to things like the relative layout, you'll actually be able to define your layouts just by dragging and dropping them from a list of text, or rather a list of views on the left, and just dragging them onto your sample screen on the right, which is a pretty nice thing to do. And you can even change how the preview will look depending on the Android version or the Android OS version. As you can see here right now, we're just previewing Android 3.0. You can even have a whole bunch of different options as well, depending on the size of the screen that you want to preview this on, and also the orientation of the screen, and a whole bunch of other stuff. But again, we're just going to look at some of the basics through this XML, and then we'll work our way towards using this WYSIWYG editor. All right, so when we're looking at the XML file, notice that it's really just a simple layout. We just have as a parent node this linear layout up here in the top few lines, which acts as a parent to several text views below. Now you'll notice one of the things about these examples here is that we actually have a couple of warnings. You'll probably also see that if you download this source code and compile it on your own machine. That's actually okay. We're going to ignore these warnings for now. These warnings are provided to us by a program called Lint, which Google has adapted for Android, or made specific to Android, and it actually does some checks for us when we create and when we compile this program, and tells you about some stuff that it thinks you could do a little bit better about your application. In this case, it's just mad at me because I'm explicitly specifying the text in this XML file rather than extracting it out and implementing it elsewhere. But again, we'll talk more about that when we're dealing with resources in just a little bit. But for now, we're going to ignore this warning just because of that. It's just sort of simple to keep all of this information right here for the time being. All right, so if we look then again at what's happening here, we have this linear layout, which is our parent view group, and it has some properties associated with it, and it has as children 4 text views. It says Hello World 1, Hello World 2, Hello World 3, Hello World 4. And each one of those has associated attributes, which changes how that one actually appears to look within the application itself. So if we take a look at some of these options, realize that some of these options will change from view group to view group. Some of the attributes that we're specifying are rather specific to the views that we are working with in this XML file. So if we take a look at this linear layout, for example, this is the element that defines it. And one of the things that I should mention is that it's probably a good idea to have this XML and namespace :Android attribute, where you specify the namespace up here in your root element. That's going to be important, or you might get some rather cryptic error from, it may not even be cryptic anymore, but at least you used to get a rather cryptic error when you try to compile this application. It's generally a good idea to have that there, but the rest then is sort of specific to the view groups themselves and not generic to all of the layouts that you should implement. So if we take a look here then at this first attribute, it's Android:orientation. And so here in the linear layout, you can specify which orientation you want the child views to be stacked. In this case, because the orientation is vertical, that means the text views that are children are going to be stacked vertically, one on top of the next. If I did it as horizontal instead, how that would change it would be, well, they would basically be columns instead of rows, like we saw just a moment ago. So that's how we can change that. One other thing, notice that we have here layout_width and layout_height. Now that's pretty important. Oh, this stupid problem again, huh? All right, so that's pretty important because whenever you see something that says layout_, as you can see here, what that means is that you are modifying this attribute for that view within the parent view, or within the object that happens to contain that view. So in other words, what we are saying is that what the width of this view itself should be is it should actually fill the parent. Now how this is different than just regular Android width, for example, is the width of the content inside of the view itself. So that doesn't make a lot of sense necessarily for the linear layout, but that might make a little bit more sense for a text view, for example, where you might want to specify a different or perhaps an input text box where you might want to specify some different widths in that context. So again, layout width tells us how wide the view itself should be rather than the content within that view. And we want to say that we want to fill this parent into the entire space that the Android device can give to us. And so for that reason, we are then going to specify that the width and the height, or more specifically the layout width and the layout height of this view should be fill parent, which then does as you would expect. It then causes that view to expand to fill in the space that that parent actually provides. All right, so if we then take a look at some of these text views, we can actually provide to it some text that we want to display. So you can see here, and we can also give to it some attributes for that text. We can give it the size, we can also change the font, we can change the color. You can see how we can do all of that in this example. But there's some interesting things that are a little bit different than the linear layout, and that is, notice the difference between the layout height of the linear layout and the layout height of the text view. The layout height of the text view says to wrap content rather than to fill the parent. So what this means is that you want the height of this view to wrap the content, to be as big as the content will actually allow, or perhaps a little bit larger, rather than having that view expand to fill the entire size that's given to us by the parent. Now we're going to talk a little bit about weights in just a moment, but all of these objects have the same weight. So with that, we can create then a very simple layout that looks just like that. If you were to start this application, it would look pretty much exactly the same as this, except in your emulator or your physical device. All right, so let's move on then. What if we want to make a layout that's perhaps a little bit more interesting? We actually want to use some of the different attributes that Android provides to us to create a slightly more interesting layout. Well, we can if we take a look at Activity04. So again, the source code itself is it's exactly the same as before, but it's really this XML file that is going to be different, that defines the layout for the objects within our UI. So here we can see we have a couple of buttons. They're sitting side by side of each other. Then there's a text box directly below it that's a single line text box, and a multi-line text box that is below that. And notice the difference in the properties of those two. The larger text box actually takes up the remainder of the space. The smaller text box doesn't even use that much width. And there's some interesting stuff that's going on here in this layout. So if we take a look at the differences here, we'll notice that we have nested linear layouts. We have a linear layout that is the parent to all of these layouts, because again, you can only have one of these parents. Then, when we want to put these two buttons side by side, as we can see here, we could then have as the first child another linear layout. But instead of having the orientation as being vertical, we can then have that child linear layout use a horizontal orientation so that we can then place those two buttons right next to each other, as you can see here. And in fact, if you notice around the buttons, there is a little blue highlight. That is the linear layout. What's highlighted right now is the linear layout that's showing us that it's using up the entire width, and we have as children to that linear layout these two buttons there. So if we take a look at some of the interesting attributes that we have here, we can see that for our width and height, or our layout width and layout height of our child linear layout, we're going to fill the parent of the width, as you saw from that blue highlight just a moment ago. It in fact took up the entire width of the screen, but we're not going to fill the parent of the height, because then that would leave no room for anything else. But instead, we're going to wrap it to the contents, whatever the height it feels is appropriate based on the content of this particular view. And notice that it has a gravity. So you can have gravity, which actually applies to the content of that view. So in this case, we want to center all of the objects that are children to this linear layout. Now, if it is in fact possible, as you can see here with these buttons, and this is a little bit arbitrary for us to do here, but this is meant to prove a point that you can actually specify where the difference between, again, the some attribute and layout underscore that attribute is where that attribute is actually modifying is actually modifying that view. So again, layout underscore gravity says that, okay, I want this view within the context of its parent view to be modified in this way, rather than the gravity, as you can see here, is going to modify the content that is held within that view group. So in this case, we're saying that the linear layout Android gravity should be the center. So that means that the children to that view should be centered within that within that view. And for this first button, we are saying that it should be pushed towards the right. All right, so notice that another thing that we have that's happening is this ID attribute. But notice that there's something kind of interesting about this. It says @ plus ID / my button. This is actually going to become very important in just a minute, and it's something that you should not overlook. It's not something that we've really done for a lot of the views so far in these examples, but it's actually going to be very important for you to create an ID. What we're doing here is essentially creating an identifier for this object, for this view, so that we can connect to it programmatically. We'll see how we can connect to it programmatically to be able to interact with that in code in just a few examples, but this is just sort of an example, or sort of looking forward, this is how we're going to be able to do that. All right, so moving on then to some of the other examples, because we could talk for days about layouts, and we really have some other stuff to get to pretty soon. We have a couple of edit texts as well. One of them, you might recall, was a little bit smaller, was a single line edit text. Another one was a multi-line edit text. I'm going to do a little bit of hand waving to some of the specifics, but there is one thing I do want to mention about these, and that is this one attribute down here in this second edit text, and it says the not the gravity, the minimum, the layout weight is what I want to point out about this second edit text. So by default, all of the views in your layout have a weight of 1. But if you give some views a higher weight than others, then those will be considered to be more important for their sizing, and it will respect the attributes that you provide to those views more strongly than it will some of the other ones that have a lower weight. So in other words, what's happened here is that we have said that we want to have a multiple line because we have a minimum line and it's, we have a minimum of 2 lines, and it is not in fact a single line edit text box. We have a multi-line edit text box, and we want it to be able to wrap the content. But there's no content in it quite yet. But what we can do is to provide a heavy weight to it through this layout weight to tell the Android OS that we actually want that to fill the remainder of the space. So this is something that's useful for you if you want to be able to dynamically resize some of these objects within your layout. So again, play around with some of these options. In fact, all of these are available to you in the WYSIWYG editor. You can right-click, or if on a Mac, you can control-click. Notice that we have access to all of these same attributes that we defined in XML, but you can also just change in the GUI as well. So notice that we have layout width, layout height, single line, what type of input it is. In this case, we just have a very simple standard string, but you can also have other types of input as well, including dates, times, and phone numbers, and a variety of other things, which changes the context of the keyboard and such, and other things that are available here as well. All right, now let's move on a little bit to Activity 5, which is a slightly different layout. And now we're going to move away slightly from using these linear layouts, because while they are useful, they are in fact rather limiting in the sorts of layouts that you can do. And in Layout 5, or rather Activity 5, we're going to show an example of using table layouts, so that you can actually create rows and columns of tables like you might in some other instances. Well, I mean, a table layout's relatively self-explanatory, I hope. Now, what's interesting, though, about table layout is that you get to define an arbitrary number of rows and columns without predefining how many it actually has. So in other words, and this is sort of what's different than HTML perhaps, you can actually have a row, the very first row, have only 2 columns, for example. So you can notice that we have nested within this table layout, the very first child is the table row, and the first children within that are the columns that represent that row. We only have 2 objects in this row. And so we basically, if we were to look at this in sort of a naive way, we might say, okay, well, as a result, this row has only 2 objects, so therefore it should only have 2 columns as a result. But in Android, you can specify an arbitrary number of rows without needing to predefine how many rows and columns this table is actually going to have. So really all we need to do is define a table layout and tell that layout that we want to fill the parent for the width and the height. We'll talk about the shrink columns in just a moment. And then for a row, we just need to provide some children to it that represent the columns that are going to be shown within that row. So if you recall from what the layout looked like just a moment ago, we in fact had a table with 3 different rows. And while it looks like most of them have only 2 columns, there is in fact the second row, which happens to have a 3rd column, a little asterisk, as you can see here. So if we look at that one, we can actually see that this row does have in fact 3 columns, or 3 views that represent one each represents a unique column within that row. But because in this first row we can actually specify which column number we want to begin with. In this case, notice that the very first text view says layout underscore column equals 1. And again, if we're thinking that these columns are 0 index, that means that this is going to be the second column. Then we can arbitrarily define how many rows and columns we actually going to have within our row. Okay, so we have 3 rows here. Just to close this idea, we have the 3rd table row down here, each with a few text views, as you can see here. And we've done a similar thing where we've actually defined the first child to this last row's view, or this last row, as the second column, so that we can push it over and leave room for that asterisk, which was in fact the first column of the second row, as we saw just a moment ago. All right. Now, table layout is also pretty useful and pretty interesting, I think. But I think one of the most interesting layouts that you're going to use perhaps most often in your Android career is perhaps to use relative layouts. This isn't to say it's going to be the only one that you're going to use, but it's going to be one of the most useful because you can specify where things are placed on screen relative to each other, rather than having to really strictly define a row in a column layout, or with the table layout, it definitely was using rows and columns. With the linear layout, it's sort of a similar thing where you have to define a number of linear layouts to arbitrarily create rows and columns. But using a linear layout, can you create more interesting UIs without much more work? So in Activity 06, can we start to create some UIs that look a little bit more smartphone-like in the way that they're actually laid out just by nature of using this relative layout? So notice what we have here. We have a couple of things. First of all, at the very top, we have a text view that asks for the name of student. Then directly below that, we have an edit text box, which is going to allow us to enter in some text within that box. If we tap it, it'll bring up the keyboard and we can type in some stuff. Then below that are two buttons, a cancel and an accept button, which are pushed to the right but are still spaced relatively evenly away from each other. And so this is going to be something that is not too bad to define when we're using a relative layout. So when using this layout, all we have to do is define each of these views that are going to be shown in this layout. So we have the text view, the edit text box, and two of those buttons that are going to be displayed. And we need to do it in a top-down, basically top-down, left to right order in order for us to do this. So if we were to take a look at this, and we wanted to start from the top, how would we define this layout in words? So recall that we have these four views. We have the text view, which is at the very top. We have the edit text. We have the two buttons. How in words would we define this layout?
Text is left justified, buttons are right justified, and the box is there.
Right. So to put it a different way, if we wanted to define it from going from top down rather than jumping from the top to the bottom and then to the middle, we might change that a little bit to say, well, okay, there's the text view at the very top. It's left justified. Then immediately below that, do we have an edit text box? And then immediately below that, do we have two buttons that are right justified? And so it's something very similar to that you can actually define in the relative layout to create this specific UI. And in fact, that's how we define it. Using the text view, we define that first. And notice that, again, this ID attribute has come up. So I just want to take a little bit of attention to talk about what's happening here. Notice that in this attribute, we have this string of text, @ plus ID / and then my label. Now it's important to realize what this @ actually means. When the Android OS is parsing this XML file and it comes across an @, it thinks that it's not going to actually process, or it's not going to just blindly accept whatever this string is, and it's going to process it. It thinks it's going to be some sort of instruction to the OS to do something. And that's exactly what's happening, is it's going to stop for a minute and say, okay, this is actually going to be representative of something rather than just a string of characters that I'm going to just accept. And what it's going to do is look at this plus sign, plus ID, and it's going to say, okay, well, what it needs to do now is to create a new identifier. And it's going to programmatically create a new identifier, not programmatically, but automatically create a new identifier that happens to be called my label. Now, this is really important because we can then reference back to this object using that ID, my label. But because we only need to create it once, in subsequent uses of this identifier, my label, you're not going to see this plus sign right here. In fact, when we define the edit text, we said that the edit text is going to be directly below this text view, which I have named my label. And what I'm doing with this layout below attribute right here is specifying exactly that. I am saying the edit text box should be directly below the object that has this ID, @ID / my label, which represents this text view that I just created the new ID for above. So notice the difference here. Notice that there's not an + sign, but there's an @ID, which says that I want to basically change this layout, or rather not the layout, but change this text representation of an identifier to whatever the identifier in memory happens to be. So somewhere there is a mapping between this text representation of this identifier. There's somewhere this mapping between my label and an integer, which represents a unique identifier for that object in this layout, within this activity. And this is going to be really important, not only within the context of this relative layout, but also very soon now are we going to connect programmatically with these objects so that we can, for example, enter text into that text box and be able to figure out what that text was that was entered, or what happens when we push a button and that button actually causes something to happen within our activity. So again, the very first time that you create an object or you create a view especially, and you need to give it an ID so that you can reference it programmatically or reference it from other objects, you need to have this identifier, or you need to create an identifier by using this @ plus ID / and then give it a unique name there. Did I see a question?
Sorry, why doesn't it just say ID equals my label? Why all the gimmickry?
Why doesn't it just say ID equals my label?
Colon ID equals my label.
So why doesn't it just say this? Well, the reason for that is that there is no, if we just did this, then we're giving it an ID of this text name, my label, but there's no integer, there's no actual ID in memory that other portions of the activity will be able to connect with. This is a way, and so to make this a little bit more real, I mentioned before that there's somewhere in memory this nebulous idea of having this mapping from one to the next. It is in fact created for us, and you will see, notice that in our hierarchy within our project, we have, of course, the source folder, the RES, the resource folder, which is where we're housing our layouts and we've been working with, but we haven't yet seen this gen folder, which is automatically generated by the Android SDK, and within that is this r.java file that actually provides this mapping. So notice that right here, there is a class called ID. There's a class called ID, and within that class, do we actually have that ID that I created, my label? Notice that it's highlighted right there, my label, and it's equal to a specific integer. And so in this way, can we then actually use this, we can actually use this as an object within our, or really as a, like this, like a constant within our application as well, and be able to reference that specific object in memory because it does have this unique identifier associated with it. So it's not meant to be confusing or gimmicky, but what it's supposed to do is provide us options for referencing that object later on in our code. Now, another important thing to realize is that when you're defining a relative layout and you want to reference an object, notice that I have referenced the my label object from our edit text, you have to have already created that ID. So in other words, I cannot put this edit text definition above the text view object and expect it to work, because that my label has not been created yet. It's reading it top down, has not been created yet, and it's going to give you an error and say my label doesn't exist yet, so on and so forth. So when you create your layout, you have to do it so that all of the objects that you're building from have to be created, or all of the objects that you are relatively positioning, let's see, let me phrase that differently. The object that you want to relatively position compared to other objects has to be defined after those objects that you want to position, or after those objects that you want to define as the root of that position object. So we then have these two buttons that need to be defined. Now notice that rather than just saying that they're right just defined, what we instead do is we want to say that it is below the edit text box, as we can see in this layout underscore below attribute. And then what we want to do is align it to the right of the parent. So it's not quite the same as calling it right justified, but it is in fact aligning it along the right side of the parent. So notice that the parent in this case is not the text view, it's not the edit text, but it is the relative layout. So whatever the right edge of the relative layout is going to be, that is where that button is going to be aligned. And because we have also said that that button is going to be directly below the edit text, it's given it no other place to put it except right here, directly below our edit text box and right along the right side of our relative layout, which happens to be, because it is, we've asked the width to fill the parent, just happens to be the same width as the screen itself. And so from this, we can then place the cancel box and say, well, okay, maybe the cancel button should be also underneath this edit text box, but to the left of this accept box. And also, perhaps one of the things we want to do is align the tops here. And in fact, that's exactly what you can see. If you actually take a look in this WYSIWYG editor, when you click on one of these objects, you can see how that relative layout is being defined. This cancel button is selected. It's to the left of the accept button, and the top of that button happens to be aligned with the top of the accept button as well. And so in our XML, that is precisely what we are defining. Our cancel button is going to have it's going to be to the left of the accept button, and it's also going to have the top aligned with the same. Any questions on that? So I recommend playing around not only with the XML, but also with the WYSIWYG editor. See how you can position things to find out how things are actually positioned. It's really something that takes a little bit of getting used to when you're first using this sort of thing. You can see all the examples in the world, but until you start dragging buttons here and figuring out how it's actually defining those buttons relative to these other buttons and modifying the XML file to see how it impacts the UI, will it be sort of a mystery. And so really then working with this will demystify that and make it a little bit more palatable and a little bit easier and perhaps even comfortable to use this particular type of layout. All right, so now we've been talking a lot about, well, how can we actually create IDs? How can we create each of these objects and all of these things? But what about now the more interesting aspect of actually connecting to those objects programmatically within our source code? And that's the point of layout 7, or rather activity 7. So in activity 7, the layout now is exactly the same as activity 6. But what's changing now is, in fact, the source code. So the source code is now going to be something a little bit different so that we can actually do something with those objects on the UI. So just to give you an idea of what's going on, I actually want to run this on the device so you can see what happens when I run this activity. So I have, one second, I have here now, you can see this is what it looks like. Now if I click on that, it brings up the keyboard and I can type some stuff in. I can hit one of the cancel buttons. Notice at the very bottom it says cancel pushed. See, there's a little message down there. If I click accept, it says accept pushed. There's nothing that's really happening quite yet, but we got to get our feet wet with actually connecting with this stuff and actually figuring out which of these buttons has been pushed and what the text has actually been entered into this edit text box. So if we take a look at the source code then for this, notice that we have within our activity our onCreate method, as always, as we expect. And the very first two lines of code are exactly as we've seen before, because we have to do this. We have to call the superclass's onCreate method, and we have to tell the activity what the view is going to look like, what the parent view is to create this layout, and we pass into it our r.layout.main. Notice again that this sort of mysterious R object has come up again. We'll talk more about this in just a little while. But now we need to connect to those buttons so that when we click on one of those buttons, we can bring up that little message called a toast at the bottom of the screen that says either cancel was pushed or accept was pushed. So in order to do that, I have to run this method that's provided to us by the activity class called findViewById and pass into it as parameter the exact ID that I want to find. Now, do you recall from the layout when I defined the identifiers for those two buttons, one of them was called accept, one of them was called cancel. And that's exactly what I'm looking for here, r.id.accept. And so this, because this happened to be implemented within that R file as a final static integer, this actually represents an integer that uniquely identifies that object in memory to this activity. So what I'm doing is I'm asking this activity to find that view and to return a view, the view that actually is shown on the screen. And when I do that, it's just returning this findViewById is returning exactly that. It's just returning a view. But because a button happens to be a specific, or happens to be a subclass of a view, we can just then basically typecast that view into a button and say, okay, I now have in this variable that I'm calling accept. Don't get confused by this various usage of the word accept. We have here this is just a variable, but whereas this use over here refers to the ID that we've defined in the layout. So there's these two different uses of the word accept that I'm using here. But essentially what's happening is that I'm creating this new variable called accept that is of type button. And a button is in fact an object. So for all of these things in the layout, the relative layout, the table layout, the buttons, all of these things not only have a corresponding representation in XML, but also happen to be objects within the Android OS space as well. So there is this object called a button that I'm defining that is named accept, and I have found then that specific button that's being displayed on the activity by using this find view by ID and passing into it the ID of that button that I want to find, and then typecasting that as a button. And then now I have this variable called accept that I can actually access using my source code, using this code in this Android application. So I do a similar thing for cancel down here. For every object that I want to connect with, I'm going to have this line of code basically that connects this specific object to its counterpart in the UI as well. But this really then allows me to abstract. This code does not care where on screen this accept button is, where on screen this cancel button is. It really allows me to separate the content from the content that I'm using here in this source code from the layout itself that I've defined in the XML file. All right, so now that accept is in fact an object that I can manipulate and work with, one of the methods that the button class provides to me is a setOnClickListener. And what setOnClickListener basically does is we provide to it a function that is going to be called when that button is pushed. When I, as the user, actually tap on that cancel or accept button, what I am saying is that I want this function that I'm calling respond to click, or rather, really, what this is an object that's an anonymous function. What I'm asking is that I want this respond to click to be fired, and for something then to happen as a result of my clicking on that button. So what then is respond to click? Well, respond to click is something that I actually implemented above this onCreate method up here. Now notice what's happening here. This is a private onClickListener. So this is just an onClickListener. So basically this is just a variable respond to click that is of type onClickListener, and I am passing into it what is essentially, I mean, you can essentially think of it as an anonymous function, but really what it is that it is an object called onClick that is of type onClickListener that has a very specific method implemented within it, onClick. So what all of this means is that in the object that I have to pass in to this function, setOnClickListener, actually has to be an onClickListener object. And that onClickListener object has to implement something called an onClick method, so that when I, the user, actually click on one of these buttons, or tap rather, when I actually tap on one of these buttons, either cancel or accept, what's going to happen is that it's going to find this object, respond to click, and it's going to fire the onClick method within that object. So whenever I click cancel, whenever I click accept, it is going to then find this object, respond to click, and it's going to fire this onClick method that causes all of this stuff to happen. Yes?
Is the way that you use an anonymous function there kind of like how the callback functions in JavaScript were working?
Yeah, so this is why I implemented it in this way first, was because this is sort of similar. This is perhaps the most analogous way that I could think of to the callback functions that we saw in JavaScript, where we would define these callback functions as a variable, or we would place these callback functions into a variable, and then we would just pass the variable into one of these. This isn't exactly the same, because we are in fact creating a new object and implementing a method within that object, but this is perhaps the closest analogy to it. So again, notice what's happening. We're actually creating an entirely new object here just for the purposes of defining this onClick method so that some stuff can happen. So what actually happens? So assume that I actually click on one of the buttons, it finds this respond to click object, and then it runs this onClick method within it. And by the way, notice that it passes into it view.v as a parameter to this method. This view is actually the view that was tapped when this listener was fired. So that's going to become very important for us in just a second. We need the application context, as we'll explain in just a second. Char sequence text is basically just a string, as you'll see in just a second. Now, I wanted to figure out, notice that what I did when I set the on-click listener for each of these buttons was I set the same listener for both of those buttons, not only for the accept button, but also for the cancel button. But you might recall that when I actually ran this application, when I click cancel, when I click accept, two different messages popped up. So it's actually deciding what message to show based on which button was actually pressed. So how do I do that? Well, I figure out which view was passed into it. Recall that this view v was passed into it. And this view is the object that was actually pushed. So as a result, if I find the ID of that view, which just so happens, as you might recall, the identifiers for these views happen to be integers, then I can use a switch to identify which one was actually selected. Does it happen to be the case that the ID of this view matches that of the accept button? Or is it the case that the ID of the view that was pushed matches that of the cancel button? And then I can change my message, or I can do something different as appropriate for each of those. So notice that all I do is I change the string that I've created above to either accept pushed or cancel pushed. And for right now, this default would be kind of bad if we ever saw this. That means that there's some object that has associated with it this on-click listener, and it's firing this on-click method, even though we haven't quite figured out, or we haven't associated any IDs in this switch with that particular object. So in order for us to create a toast, or that little message that shows up at the bottom, it's a relatively simple sequence of things. First of all, we need a duration for that toast. How long is that message going to be shown on the activity? Then we're going to create the toast itself. We're going to make the text, provide to it the context, which I'll explain in just a second, the text, which is the message that I've defined above in the switch statement, and the duration, which I just done a moment ago. And then when I actually want to display this message, I can use the toast, or I can use the show method for that toast object. Now the context is something that is pretty interesting as well. And what the context is basically just this sort of nebulous idea of the entire application. The context itself is used by the Android OS to define the activity, what the processes are for that activity, the application. There's a whole bunch of stuff that's associated with that context. And basically, you can think of your program, your application as a whole, as being within the context of itself, right? You have this one application and it has a context that is specific to that application. And perhaps if you were to run another application like Google Maps or the phone application, for example, then the context is different because it's no longer your application, it's no longer your task, but instead the context of that other application as well. And so when we are displaying the toast, it has to know the context that it's going to be displaying the message, and we pass into it the application context representing our own application. And so here we have get application context, but there's another way that we would be able to get the context as well, and you'll see that in future iterations of us using this toast message. So I mentioned before that this is one way that we can programmatically connect to our objects in our UI and have something happen when we actually click on some of these buttons. But there's a downside to implementing this in this manner, and that is what I mentioned before. We have this additional load of creating a new object. We're actually creating a new object, so we're using additional bytes in memory, when in a mobile application, that's something that we really want to try to avoid doing. So is there a way that we could avoid this additional object creation load, but still have similar functionality? In fact, of course, that's a leading question because the answer is yes, but we'll find out how we can do that after the break. So in 5 minutes, you will find out the answer to that. Hello everyone, welcome back. So before the break, we were looking at how we can implement on-click listeners so that we can be able to cause some event to fire when somebody actually taps on one of the buttons in our code. But I mentioned that in this activity 7, this actually isn't probably the best way to do this because we have the additional object load of creating that additional on-click listener. And so what activity 08 then attempts to do is to fix that problem so that we can implement the on-click listener in a different way. So this is the onCreate method for that activity, activity 08. Again, it's the very same relative layout with the cancel and accept buttons, so everything that you're going to see is going to be very similar to that, where we call the supers on create method, set the view, so on and so forth, connect programmatically to that ID that we've created. But notice that we have, instead of passing into it an object, what we are doing is passing in this keyword of this to this on-click listener. So what does this refer to?
This class.
Right, so this object, this class that we're working with, this is the activity class that we are in fact working with. But how then are we able to tell Android that we want this class to also behave as an on-click listener? Well, take a look at the very top. When we first define this class, we're defining code 8 extends activity as we've seen before, but it also implements this thing called on-click listener. So on-click listener is basically an interface, and what we are saying by implementing an on-click listener is that we are guaranteeing that somewhere within our class we're going to implement that on-click method with that one parameter view v, so that we can then do something when we pass this object, our own object, this activity, into this on-click listener. We've also happened to do through this, we've implemented another on-click listener as well, called an on-long click listener. So rather than just single clicking on that, or single tapping on that object and letting go, we can also click and hold, and something else will happen as a result. So just to show you how this is going to work, I will compile and run on our device, and it's installing, and I'm going to move to, whoops, let's go to the document camera so we can see here this is activity 08. So if I could cancel, you can see at the very bottom the toast appears. It says cancel clicked. Same with the accept. But if I click and hold accept, you can see that a different message comes up altogether. It said accept long clicked. And the same thing happens for cancel as well. So then I've been able to implement several different types of events within this one thing within this one activity without creating additional objects that have to be loaded in memory. So how then are we able to do this? Well, realize that we have to implement that on-click method, and I've implemented that below. And it looks very similar to what we saw before, but I cleaned it up a little bit. I implemented that toast message notification in a separate method called show message, where I pass into it some text. You can see what show message looks like up here, which is basically just the similar things we saw above, just factored out into this separate method. And when something is clicked, then I use the same method as before, where I use the switch to determine which one was actually clicked, and I pass that text into the show message method and proceed that way. And on long click is something that's very similar, but I'm using something just slightly different to be able to achieve a similar thing. What I'm doing is I'm taking this view that's being passed to my method as a parameter, and rather than just accepting it as a view, I know that the only two views that are using this are buttons. So I'm in fact going to then typecast that to a button and say that button has been, I'm going to call that as pushed, because that was the button that was in fact pushed. And what I'm going to do is to get the text from that button. So this then is a method that is implemented by a view that actually tells us what text is being displayed in that view. In this case, it happens to be the message either cancel or accept, because that was the text that was actually shown on those buttons. And that's why it looks slightly different. That's why it says capital A accept when I long click it, rather than lowercase accept, because when I typed that message in the above method up here, I just used the lowercase accept rather than pulling directly the text out of that view by using the pushed get text method. Now notice that the on-long click method is implemented because we specified that we're implementing the on-long click listener, but also this method happens to return a Boolean. So if we successfully handle that message, or this on-long click event when it occurred, then we need to in fact return true. So perhaps in more complicated examples, would you need to return false if for some reason you decide that some event has not been handled properly when it was long clicked. Perhaps you have multiple events, multiple event handlers, or multiple objects that have on long click listeners and that sort of thing, and then you would have to make that decision then about whether or not you have appropriately handled that. Now, I have to say that using a toast everywhere is sort of like using an alert box in JavaScript. There's times that you might want to use it, but it's really not the sort of communication that you want to have with your user a lot, because it's kind of quick and it's kind of dirty. And there's certainly cases when using, and I guess the analogy isn't perfect, because there are certainly times when using a toast is very appropriate in the context of an Android device. If you just have a very quick, brief message that you want to display to the user that is relevant to their action, then it's certainly a good idea to use a toast. But perhaps instead, we want to have a better dialogue. We actually want to show a dialog box to the user instead of having this toast option. And that is exactly what Code 9 or Activity 09 is implementing, is in fact a dialogue. So so very much like the other examples, this is using the same relative layout and the same layout that we've seen up until this point, and we're going to connect programmatically to it. I'm getting rid of the on long click listeners. That was just an example in the last one. We're going back to on click listeners that we're implementing in our activity. Our onCreate method looks like it did before, where we connect to those buttons programmatically and set the on-click listener to our own activity object. And so something then has to happen. Notice that we're also connecting to the edit text, or that text box that allowed us to enter in some text using the keyboard. Find our text field by its ID in this line here. And this will become relevant in just a moment. All right, so if we actually take a look at what's happening in this new example, I'm actually going to type in, so it says ask for the name of the student, so I'm just going to type in J space Harvard. Hopefully this isn't going to take me too long. J Harvard. There we go. Oops, I didn't tap it properly. And I'm going to hit accept. And it tells me now in a dialog, notice that it's very different here. It actually requires user intervention, and it tells me exactly the text that I've entered in. And in fact, in this case, you can see that I happen to enter an errand space just because I used the autocomplete, and it used and it also provided a space immediately after the word Harvard. And so what then is happening here? Well, if we take a look at the on-click listener, or rather the on-click method that we have to implement because of our interface, we can see that it's very simple. We're deciding which of these two buttons we're actually pushing, and we're going to do something dependent on one of those two buttons. I suppose I should actually also show you what happens when I click on the cancel button. It just asks if I'm sure I want to cancel. If I click yes, notice it, all right, I should probably do that in a slightly different way. Notice that what happens when I cancel, if I just run this on top of just this application on its own, and rather not on top of a stack of stuff, if I hit cancel and click yes, it does in fact close that activity. It wasn't quite so obvious before because our task was involved a whole string of activities of all of those other applications that we've seen up until that point. That's where that distinction that I made early on in our discussion about Android, the difference between an application and a task really comes into play. When I clicked cancel before, and it sort of slid off to the side, and we saw the previous program, that's because this was the newest activity up on top of the stack, and really all it did was just close that one activity. But in this case, when I had that activity all by itself, the task consisted entirely of my single application, then closing that activity essentially seems to have closed that application to the user. So there's a couple of different things going on here. When I click accept, it fetches the text from that edit text box and displays it in a dialog. When I hit cancel, it asks if I'm sure, and if I'm sure, then it will in fact close that activity on the task stack. So notice that we have here, we're calling this method called show dialog. And this is a little bit of a leap of faith every year for some students, but realize that show dialog is a method that's implemented by activity somewhere else, by the activity class or by some other class somewhere else. And what that method actually does is it basically is as if this dialog box has a life cycle of its own. very much like, in an analogy would be using this onCreate method, we no longer have this main method in our applications when we're working with Android, but in fact, because of this activity lifecycle, the very first method that's being called by some other object somewhere else is in fact this onCreate method. So basically for us, onCreate is this method that we then, is essentially our main method for this activity. And that's a bit, I mean, you shouldn't think of it that way. It's not that at all, but I mean, we can sort of think of it at least naively as our main method within the context of our application. And so similarly, there is implemented somewhere else a method called showDialog that goes through a life cycle basically for a dialog box. And so when it is ready, when this method is ready to create the dialog box, it is going to call a method called onCreateDialog. Excuse me. So the reason that this is a little bit difficult is that, or difficult for some people at first, is that there is the difference. What we are calling is not onCreateDialog here. What we are calling is this method called showDialog, and it seems as though there's this magic happening behind the scenes. But just realize that this is just a method that's been implemented elsewhere that has to go through a sequence of steps in order to create and display this dialog for us. So this method is doing a lot of the grunt work for us, but it is still our responsibility to create the dialog box that we want displayed by this method. So notice that what we're passing into this method is essentially just a static integer that I've created called dialog_acceptID. Now I've defined that at the very tippy top of this source code. We can see up here there's an accept and a cancel, and I've just applied static integers to them, and we'll see why that's going to be useful in just a moment. So this showDialog method then has been passed an ID for the dialog that I actually want to display, and then somewhere along the steps of showing this dialog, does this method realize that it has to create the dialog? So it calls this method called onCreateDialog that we have to implement so that we can create the dialog box that we want this method to show. So we don't implement showDialog. What we implement is onCreateDialog, but we call showDialog for all of this stuff to happen for us. Okay, so we get to this point then. onCreateDialog, notice that it returns an object of type dialog, and it also accepts an integer ID so that we know which dialog it is that we want to create. So in order for us to create one of these, we're going to first instantiate an alert dialog and an alert dialog builder, and it's using this that we're really going to be able to implement our dialog. So we're going to have a switch then, dependent on which ID was passed to us. Let's first take a look at the accept one, because that's the one that we looked at first. So in the case that we want to build an accept dialog, which was distinct, if you recall, from the cancel dialog, then we have to go through these steps here. So we reference our builder object, which we had just created just a moment ago as an alert dialog.builder. And within this object, do we set the message, you've entered this text. Now recall that I've actually connected this object, number students, to that edit text from our UI. So we have access then to this object and this object's properties and methods, so on and so forth. But also notice that when I defined this variable, I defined it as a field variable that's accessible not just to onCreate, but to everything within this activity. So before, when I defined these buttons and when I defined the edit text, I did it just within onCreate because no other methods needed access to those objects. But in this case, it is the case that I do want my edit text object to be accessed from other methods, so I have to be sure that I define those variables up here and then connect to them using the same method that we saw before to those objects within the onCreate dialog. Is after, by the way, we've created the views and the layout. And then what that means is that in onCreate dialog, can I get the text, or call this getText method from this number students object that's been created before and is now, now we can reference within this one method to create the message that is being used in this dialog box. Now, one of the nice things about this builder object is that all of its methods then return itself. It returns its own object, so that means that I don't have to create a whole bunch of things like this. I don't have to do this. Builder equals builder.setMessage, and then I have a semicolon at the end, and then builder equals builder.setCancelable, so on and so forth. I don't have to do that because it happens to return itself as an object. Then I can just continue calling methods on the returned object. So in other words, you can see here that I have builder.setMessage. This is going to return that same builder object, so I can call another method here, setCancelable, which basically says whether or not the user can hit the back button on their phone, the actual physical back button, to cancel the dialog box. In this case, I don't want that to be the case. And I can define a sequence of buttons. So I can set a neutral button, which has the text that's shown on the button itself. And then I have also an on-click listener for that button. But because I don't need that on-click listener for other things, I'm really just going to create it anonymously like I did before. Create a new dialog interface.onClick listener, pass into it an on-click, or implement an on-click method within that object, and call this method dialog.dismiss, which will then dismiss that dialog when I want it to actually be closed. So this was that one example, or this was that one result that happens when I click that accept button. What we saw was precisely what we have implemented. So I can type some stuff here. I'm not going to go all out. I'm just going to click accept. And now we can see the exact result of what we saw before. Cool is the text that we defined in that when we're creating that neutral button. When I click on it, it runs that on-click listener that then dismisses the dialog. So then there's this slightly more complicated dialog in the cancel button, the yes and the no button, though it has a very simple message. If I click no, most likely you can imagine that we're just going to dismiss the dialog in that case. But when I click yes, that means that we wanted that activity to come to a close. So if I then take a look at that, at the implementation of that, we then are creating, again, using the builder, we're setting the message to be something relatively simple like we saw before. I sure you want to cancel. And then we have two buttons. We want to create a positive button and a negative button, and we want to have on-click listeners for each of those. So in the case of the negative button, then we would just call dialog.cancel. We don't necessarily want to dismiss it. There's a distinction between just dismissing it, which means, okay, I acknowledge, and actually canceling the action that was about to occur with this dialog. Or in the case that I actually say, yes, I'm sure I want to cancel, then I want to run the finish method on this activity and close that activity from running. Yes?
Why is there a distinction between set positive button and set negative button if you're choosing the labels in its action anyway? Why isn't it just set button? It says, the dialog is yes, and when you do it, it runs this code.
Why is there actually a distinction between the positive and the negative buttons? Because you don't, what we're doing is overriding some of the default options, and I think that you don't have to do that necessarily. So it might also be a difference in the way that the button is styled as well, and the Android OS may not actually have shown it on this particular version, but perhaps other versions will actually highlight one or the other depending on which one is actually the affirmative or the negative version, and so on. There's probably a variety of reasons related to that sort of thing. All right, now there's one additional thing that I have to mention here. We've created our dialogues. Recall that in order for us to first show this dialog, we ran the show dialog method that then was responsible for creating and doing a whole bunch of other stuff, displaying that dialog for us. But there's one thing that you have to keep in mind when you're working with dialogues, and that is once you have created a dialog for a specific ID, it has already been created, and it is not going to be updated anymore. That dialog has been created, and it's going to be cached. That object is going to be cached in memory so that it doesn't have to be recreated in case that dialog happens to come up again. So what this means is that if we have a dialog like this that could actually change dynamically from one iteration to the next, that we probably have to have some way of updating that dialog once it has been initially created and once it's been cached by the OS. And so there is yet another type of method that we can implement called onPrepareDialog. And so this method is actually called after onCreateDialog. And rather This show dialog method now, you can start to imagine, is becoming perhaps a little bit more complicated than we might have initially guessed, where it's actually going to first call this onCreate dialog, and on subsequent iterations for a specific ID, if that dialog has already been created, it's just going to load it from cache rather than recreating it using this onCreate method. So what's going to happen then is if it has been created already, and it needs to, and we're calling this show dialog again on the same ID, it is going to then call this method instead, onPrepare dialog. And what our responsibility is then in this method, if we decide to implement this method, is to update some aspect of that dialog that's already been created but needs to be updated because some state has changed or something has changed in our activity. And so in this case, because it just so happens that our edit text could change from one iteration to the next, I have to update the message based on the new text that's been input into that edit text object. So again, just because of the fact that in order for us to save some electrons here, the show dialog method is going to cache the already created dialog for a specific ID. And it's not going to update it or recreate it for you. If you want it to be updated when some change has occurred, then you have to implement this onPrepare dialog method where you can do exactly that sort of thing. Any questions on this? Yes?
ID that's past the show dialog, could that be r.id.accept also? Like, do you need to create another instance?
Yeah, absolutely. The ID that we pass into show dialog could in fact be r.id.accept. In fact, we could, that is one of the ways that we could simplify this method, would be to just show dialog and then pass into it the ID of our object there, and not deal with this switch. Then, of course, we would then need to update. We would need to update not only the onCreate dialog method, but also the onPrepare dialog method to accept those IDs instead. But yeah, that is certainly a viable option as well. All right. So there's one more type of layout that I want to show you, and that is implemented in Activity 10, and it is, in fact, a list view. And so a list view is slightly different than some of the other views that you might be familiar with because it, in fact, changes our definition of an activity. So this is a list view. We have a variety of colors, and if I select one of them, little toast message shows up showing which one I had actually selected. So you can see I can click one of these and something actually happens depending on which one I'm doing. Now, this is not actually a layout that we would define in an XML file and connect to it as we've seen in all cases before, but there is in fact a separate type of activity altogether that's specific to this type of listing. In fact, if you take a look at our declaration for this class, we're no longer extending activity, but what we are extending is in fact the list activity, which is going to be responsible for taking care of a lot of these things like that scrolling action and some of the other stuff. So it makes it a little bit easier for us, but you just have to realize that when you want to use a list like this, you have to switch context a little bit in your brain and use a list activity rather than the activity that we've been accustomed to up until this point. Now, a list activity has all of the same hierarchy and life cycles as the original activity, but there's just a couple of things that are different. Notice, of course, that when an item is clicked, we are still going to implement an on-item click listener. This is slightly different from the on-click listener that we saw before. It's a slightly different interface, but it still is something that we must implement when we click on one of those objects within our list. But if we take a look at the onCreate method, notice something that's very different. We no longer have the setContentView method within our onCreate method. There is no setContentView. All we're doing is we're calling our superclasses onCreate method, then we're diving right in to this activity. And what is happening in this activity? Well, we have to have this object called an adapter. And what an adapter does is it is responsible for actually passing a list of items to this list activity that list activity will then display on our behalf. So an adapter is meant to be relatively generic because, as you might recall from our earlier example of the NPuzzle game, it can in fact be an arbitrary list. It doesn't just have to be a list of text, for example. It could, in fact, be something like an image and a name, for example, that has an ID associated with that specific item in our list. And so an adapter then can simplify all of this idea of having this complex set of images and views and layouts and IDs that are associated with a specific object into something that makes it a little bit easier for us to work with in our code. So when we create a list activity, we have to run this method called setListAdapter and pass into it an adapter that is going to be responsible for these lists of items that is going to display on our behalf. So in this case, I'm just going to use a very simple array adapter, and that's going to be of type string. Notice that here in these angle brackets, I'm telling what sort of data I'm going to be using within this array of objects. And in this case, it is going to be a string. And I'm going to pass into it this data set, colors, which I have defined down below as just an array of colors that we saw in the list. So really all this adapter is responsible for doing is just, and it might feel like a little bit of overkill in this implementation because all we have is just this array of colors that we want to pass into this list. But again, the strength isn't so much for the simple examples like this, but when we start looking at more complicated examples, and we'll see another example next week when we look at basically a gallery of images, the adapters then, their power really comes to light in these more complicated examples. But just for now, take for granted this idea that we have to use an array adapter and pass that adapter into this setListAdapter so that this list activity knows what data to display in the list. So once I've passed into this activity, the array adapter, notice that I have set some layout for this, but this is for an individual item. Notice that there's r.layout.custom list item, and in fact, if I look in my resource folder under layout, I have defined a single object in an XML file, a single item that will be displayed. And this is why that list looked like it did, because I defined a text view that's going to have an enormous text size and a relatively large amount of padding. So I could change this, and it's going to change the way that it's actually viewed, the way that this object is actually viewed individually in this list adapter, or rather in this list view. But this is just a single object that I pass into this setListAdapter. So I pass into it the data that I want to deal with, which was colors. I'm passing into it the layout of the individual item that I'm going to deal with, and it will then take care of creating that list for me that I can then connect with using this subsequent method right here, getListView. This is the list view that has been created on my behalf using by the lists activity and the data that was provided by the adapter. And I can set a variety of properties associated with this list view, like this set text filter enabled. If you happen to have a keyboard displaying on your screen at the time, you can actually filter the list based on typing in some initial key presses. So for example, well, let's see, would I be able to show this on the other one? I hope so. Let's do this on the emulated device, which actually displays a keyboard for me. So now hopefully this is going to work. Live demos. If I type O, it filters the list, and this is very useful for very long lists as well. You can see that I started typing orange, and it shows me the one object that resulted in that. And then I want to implement an on-click listener for when I actually click on one of those items within my list activity. And I have already mentioned before that I set myself or this own activity as the on-item click listener, and I'm going to use that to listen for the item that has been clicked and then display that in the toast. So again, this is just a different way that we would be able to show a list of things. You're not going to use a standard activity, but you will use, in fact, a list activity when you want to display a whole bunch of stuff taking up the entirety of your list activity. And we'll be able to style this. You're going to see another example of this next week when we start dealing a little bit more with intents and that sort of stuff. But this is just to get your feet wet with this idea, just to get that get the juices flowing a little bit and to get you in the right mindset for that. Now, if we switch gears just a little bit, there is in fact a few other things that we need to talk about today, and that is dealing with some of the resources. So up until this point, we've done a lot of hand waving at this resource folder that we've dealt with somewhat, but we haven't actually worked with directly. So realize that the resource folder can have a certain set of subfolders within it, depending on what sort of data we actually want to display. So we have drawable, which can actually display a variety of icons. So notice that icon.png is actually there, and that is actually the icon that's being displayed on the home screen for that application. We have the layout folder where we define all of the XML files for our layout. And now we have values. And values isn't something that we've seen before, but notice that we have colors.xml and strings.xml. And in fact, there's a variety of different types of resource folders that you can actually display. For example, you can have an animation folder, so you can define frame-by-frame animations. In Drawable, you can place a variety of images that are going to be bundled with your application. Layout, we've already talked about. Values are things that are going to be compiled XML files, and you can use as a resource in a variety of contexts, as we'll see in just a little bit. XML is just arbitrary XML files that you can use within your application, perhaps within your code itself, rather than referencing from layouts and from other things like we would perhaps use values for. And raw is raw, uncompiled files. But there's an important distinction between resources and assets. So resources are something that we can actually access using this R object that we've seen referenced to a couple of times today and in the past. And this is typically things that we just saw examples of just a moment ago. So XML files and some relatively small images and that sort of stuff. But if you actually have lots of raw data that you want to read byte for byte, then you would perhaps instead use the assets folder, because anything that is inside the resource folder can be touched by the compiler. It can be optimized in some way. It can be, if it's a JPEG or a PNG or some image file, it can actually be changed and modified by the compiler to be optimized for the device. So that's important to keep in mind. If you actually want raw bytes, then you have to use the assets folder. But if you're okay with some of the things being optimized by the compiler, then you can place them in resources. And so assets are going to be for things that you really need to access the raw bytes for. If you have I don't know, perhaps a lot of music files or arbitrary types of let's say you're creating a new type of music codec, for example, and you actually need to read the raw bytes of the music file, then assets would be the perfect sort of directory to place that particular object. So there's a lot of things that you can place into these resource folders. And it's also, there is one important thing that I should mention. Anything that you place within the resource folder can only have, the names can only be the subset of characters of lowercase a to z, the numbers 0 through 9, an underscore, and a period. And I think that's it. You cannot name any resource files with an uppercase letter. It's going to yell at you and it's going to be confusing. It's like, why on earth can I not name it this way? Especially if you are working with a lot of images, for example, it might be very easy for you to just copy or just to drag some images from your digital camera, for example, and drop them into the resource folder. So you might have a lot of images that are named something like this, capital IMG underscore 0123 or something like that, .jpeg. Which looks fine, but because IMG is capitalized, it's not actually going to allow it. So you're going to have to rename all those files to be their lowercase equivalent. So that's just sort of a gotcha to watch out for when you're working with the resource folder. Again, that's just sort of an optimization that has to happen, I guess, for the Android OS. So there's additional information about resources on the developer site, but there is one more thing I want to mention about resources as well, regarding the resource folders that are contained as well, and that is that you can actually specify a number of folders, especially like drawable folders, for example, and be able to define very explicitly different resources for different types of hardware, for different types of configurations, for different types of OSs, so that you can really target your application to have different resources for different types of devices that might be running your application. So here, for example, we can define a drawable folder with different language types, different screen dimensions, different pixel densities, And there's a set of rules that Android will follow, the Android OS will follow, depending on which of those objects or which of those qualifiers actually match the configuration of that device. So you can actually get some pretty fancy things happening as a result. So here, for example, there's in bold a resource drawable folder that's specific for English US. It's going to be in portrait mode with medium DPI, and it's going to be a finger touch screen versus, say, a stylus or no touch screen whatsoever. So if there happens to be a device that matches those characteristics, then this drawable folder will be used for that particular device. So you can really get specific with some of the drawables that are contained within your application. And this is one way that you can really make your application specific to all of these various types of platforms and devices that your application might actually be run on. Now, to come back to this idea of the resource folder, notice that I have defined in here a colors.xml file. I've given it a name, and I've given each of these examples a name for different types of colors. So red, for example, translucent blue. Notice that you can also define a fourth byte as well when you're defining one of these colors in Android to define the alpha transparency of that color, and as we're doing for this translucent blue. And because we are placing this colors.xml file within our resource folder, it is actually going to be compiled by our compiler into this R class. So we can actually see then that we have specific identifiers for those two objects in the XML file in that colors XML file. We can see we have an identifier for red and an identifier for translucent blue. So what this means is that you can use these objects not only in your program, not only in the code, but also in other XML files as well. So if, for example, we were to take a look at the layout that we've defined for this object, we can actually see that the text color that we want to describe for this very last text view is in fact the color red. So at color means that I want to use this color XML file, and the red means that I want to use that red identifier, or that red object that I've created, or that red element rather, that I've created within that color XML file. So we can define then, and this is one way that you can imagine that we would be able to define strings as well. In fact, for those of you that are thinking about creating applications and you want to make them multilingual, you actually want to be able to support multiple languages in your application, this is exactly how you do it. You would create different resource folders for different languages and the Android OS will display the appropriate resource folder dependent on the exact language that was displayed. So recall just a moment ago that we showed an example for drawable. If we had drawable-en, for example, that meant that was going to be specific. That drawable directory was going to be specific for devices running English language. But in this application, in Intense02, can we actually see that we don't have two drawable folders, but we have two values folders, one for English and one for Spanish. And in this way, the Android OS is going to automatically pick the appropriate XML file, or rather the appropriate directory to pull the XML files in so that we can have an application that supports multiple languages. So notice that in each of these directories, we have implemented strings.xml. So there are identical XML files in each of these directories, but one of them happens to have strings in Spanish, and one of them happens to have strings in English. And so how then do I use these strings? Well, it's exactly like what we've been talking about up until this point. Notice that I can reference the string by using the @string /hello differentiator right here in our Android text. This is frustrating. Try this one more time. It's right here in our text view. Do we not actually explicitly put some text as we had before? And you might recall that I mentioned, there's some warnings associated with this. We had some little warning signs because we explicitly put some text in this attribute. Well, no longer am I doing that. I've now factored out that text, placed it into this strings.xml file within this the values-en and values-es directory, and the Android OS will pick the appropriate strings.xml file based on the OS, the language that the operating system happens to be set to at runtime for that application. So here we can see that all we are doing is referencing this string called hello in this strings.xml file. So here we can see that I've defined that string hello as being hello world intense02, or just say, yeah, hello world intense02. So if I actually run this application then, we can see what exactly is going to happen when I display it on, let's see, on a device that's running in English language. We can see exactly that. It says hello world intense02. Now if I change the language on this device to Spanish, under settings, language, select language, Spanish, United States Spanish specifically. So notice that everything's now in Spanish, but notice how some of the names of the applications have also changed, but only some of them. Some of them have actually changed, like the browser, for example. Angry Birds hasn't changed, nor has the NPuzzle staff solution. So what's happening is that those applications perhaps don't have a values folder, a values directory for the Spanish language. So the OS is smart about picking which one. It's not going to require the fact that there is a Spanish version, but it will pick the appropriate one depending on what you happen to make available within your application. So I have here intense02. We can see now that it has picked a different string from the other resource directory. So you can localize then your applications using this particular method. The resource, using this resource hierarchy is a very powerful way of localizing your strings to various types of languages, but also to localizing it, making it very specific to the different types of devices that your application might run on as well. All right, any other questions or any questions on that? Yes? Is there a way to have a language choice within the application yourself? Yes, but I suspect you'd have to implement that on your own, and you'd have to have different XML files and do that sort of thing. This, the resource, when the Android OS picks the appropriate resource folder, it does that based on the settings that are set on for the entire OS. And so that's why I had to set the language for the entire operating system, because it was that when Android actually ran my application, it then picked the resource folder that was appropriate based on the system settings and not some settings that I'd set within the application itself. So you might, if you wanted to do that, I suspect you will have to actually implement implement using different languages or multiple languages on your own in the application. But that's probably not such a big deal. If you actually wanted it to always display a different language, then you can just implement in your values, you can just have a single values directory and implement within that directory just whatever language you wanted to implement that application in. But if you wanted to have a mix of languages, that's something you'll have to implement on your own. All right, there's just a couple more that I want to show. Intense03 is pretty neat because now for the first time can we actually be able to display images within our applications. We're going to do that by placing an image in the drawable directory. We can see what the image looks like over here. It's just this image. And we did that because we had created an image view within our layout. If we take a look at the layout file over here, we just have this, and we have placed within it the source of that image is in fact going to be an image that was placed within the drawable directory. So at drawable/image_1998. And we can, if we take a look at the drawable directory, we will see that we have in fact placed that image within the drawable directory. But we could also change that as well. If I wanted to pick another one, I happen to have, let's see, I think looks like I also have 2000 in there. So I could recompile this, run it, and I don't want code 9 changed. Do you want code 3 changed? What did I do? Uh-oh. Live demos. Okay. Well, that expired a short while ago, so I'm not going to fix that, but we could update this, and we could actually see now a new image. If I were to recompile this and then run it on my device, we would see a new image that had been displayed all by using the same resource idea from before. But notice that here I've connected in my onCreate method to my image view. And then I'm saying that I want to use the setImage resource. And what will happen then is it will actually find the resource, and it will find that resource within the drawable directory, and then it will show that within the image view. This is a pretty useful way of doing it, but I'm going to give you a small hint with regard to NPuzzle, and this is not what you're going to want to do with NPuzzle necessarily, because you really, this obviously is not a good way of creating tiles from this drawable resource right here, but this is a way that you'd be able to just display an image that you happen to have in your resource directory. And finally, Intenso 4 is sort of a neat way, it's sort of a neat thing for us, because it's also the first thing, it's also the first application that happens to have some sound in it. And so if we actually take a look at Intenso 4, well, we get this lovely thing, which is a force quit error. So I test this, let's see, I think it works on the emulator. Let me try it on the emulator instead. Hopefully it will load on the emulator. In a moment. Otherwise, this will have to be an